Hello everyone, I'm Dr. Buddhika Liyanike. Today's topic is stoichiometric calculations in chemical equations. Let's go and learn about the moles, grams, molar mass and the molecule concept. How we can interconvert each of these terms in sample problem solving. Let's talk about the first question. Consider the combustion of butane C4H10. The combustion reaction is given. This reaction is balanced already. The question is, in the above reaction, 5.5 moles of butane reacted. Calculate number of moles of carbon dioxide formed. So before we move on to question, let's go and find out how we can read a balanced chemical equation. Balanced chemical equation read 2 moles of C4H10 reacted with 13 moles of oxygen to produce 8 moles of carbon dioxide and 10 moles of H2O. These numbers 2, 13, 8 and 10 we called molar coefficients. These molar coefficients gives us idea how many moles of each reactant reacted and how many moles of each product are formed. How we can add these coefficients? These are the coefficients we use to balance the chemical equation. Number of each type of atoms. Number of carbon atoms in the reactant side, balance number of carbon atoms in the product side, adding these coefficients. Now let's go to the question. 5.5 moles of butane and carbon dioxide. There are two chemicals are talking about in this question. Butane and CO2. We don't need oxygen or H2O. So let's pick only butane and carbon dioxide from the equation. What is the molar ratio? 2 moles of butane reacted. In the product side, 8 moles of carbon dioxide produced. Molar ratio between butane and carbon dioxide 2 to 8. Another way we can say it, if you further simplify, 2 to 8 means 1 to 4. If you divide both sides by 2, 1 to 4. First step is read the equation and try to understand molar ratio between two chemicals are talking in this question. So after you identify the molar ratio 2 to 8, let's build a conversion factor. Conversion factor means a fraction. This equality you can write as a fraction. 8 moles of CO2 divided by 2 moles of butane, C4H10. You can write another conversion factor by switching numerator and the denominator. However, we need only this conversion factor for this calculation. How many moles of carbon dioxide produced by 5.5 moles of C4H10? 5.5 moles of C4H10, the given quantity multiplied by the conversion factor we selected. We select this conversion factor because moles of C4H10 we need to cancel. So whatever the units in the given quantity, the same unit should be in the denominator, in the bottom part of this fraction. Then we can cancel moles of C4H10 to moles of C4H10. The remaining units is moles of carbon dioxide. Now numbers. 8 divided by 2 is 4. 4 times 5.5 is 22 moles of carbon dioxide. Step number 1 is read the balance equation. Step number 2 is pick the required two chemicals mentioned in the question. And then based on that molar ratio build a conversion factor and then you can solve for the final answer. I hope you will understand the first question. Let's go forward. Second question. When making soda, chemical formula is sodium bicarbonate or we call sodium hydrogen carbonate. When it is heated, it releases carbon dioxide gas. Write the balanced chemical equation. This is balance equation. Sodium bicarbonate 2 moles. When 2 moles of sodium bicarbonate heated, it decomposed into sodium carbonate plus carbon dioxide plus water. Now using this balance equation, part B, calculate the mass of sodium bicarbonate required to produce 20.4 grams of carbon dioxide. So if you have a gram quantity, the first step is convert it into moles. How many moles of CO2 using molar mass of carbon dioxide? So carbon dioxide molar mass 44 grams per mole and carbon dioxide grams 20.4. So molar mass divided by molar mass gives number of moles. Mass is 20.4 grams divided by 44 is equal 0.464 moles of carbon dioxide. Next, let's go to the balance equation. According to balance equation, 2 moles of sodium bicarbonate reacted to produce 1 mole of CO2. Molar ratio is 2 to 1. So whatever the amount present here, sodium bicarbonate, always half of that amount CO2 produced. Now after you identify the molar ratio 2 to 1, 0.464 moles of carbon dioxide produced, that is 2 times of 4.464 amount should be available, sodium bicarbonate, that is 0.927. Because molar ratio is 2 to 1, any amount of carbon dioxide present should be double for the sodium bicarbonate. So 0.464 amount carbon dioxide means 2 times of that sodium bicarbonate should be there. So 2 times 0.464 is 0.927. Now we need the gram quantity. So sodium bicarbonate molar mass 84.007. If you multiply the molar mass times the number of moles together, then we can get the number of grams. Sodium bicarbonate mass 0.927 moles times molar mass is equal 77.9 grams. Third question. Silicon tetrachloride SiCl4 can be prepared by heating silicon in chlorine gas. You can see the balance equation is given. 1 mole of silicon react with 2 moles of chlorine to produce 1 mole of SiCl4. In one reaction, 0.665 moles of SiCl4 is produced. How many moles of molecular chlorine were used in this reaction? There are 2 chemical species stated in this statement, SiCl4 and molecular chlorine, Cl2. So from the balance equation, you need to focus on Cl2 and SiCl4 only. Then what is the molar ratio? 2 moles of Cl2 reacted to produce 1 mole of SiCl4. Molar ratio is 2 to 1. So any amount available here for chlorine, half of that amount produced for SiCl4, 2 to 1. So 0.665 moles of SiCl4 produced means double that amount. 2 times 0.665 amount of chlorine should be there. Then this is the connection. SiCl4 amount, double that amount, 2 times of that amount of chlorine should be there. The molar ratio is 2 to 1, reverse side 1 to 2. 0.665 moles of SiCl4 produced by 1.33 moles of Cl2, 2 times 0.665. Fourth question. Fermentation is a complex chemical process of wine making in which glucose is converted into ethanol and carbon dioxide. So this is glucose fermented into 2 moles of ethanol plus 2 moles of carbon dioxide. Now starting with 465 grams of glucose, what is the maximum amount of ethanol produced in grams and in liters? There should be 2 answers. Density of ethanol is given 0.789 grams per milliliter. Now we are reading chemical equation using moles, number of moles. 1 mole of glucose, 2 moles of ethanol, 2 moles of carbon dioxide. Therefore, the first step is the gram quantity of glucose convert into moles of glucose using glucose molar mass. Glucose molar mass 180 grams per mole. 465 grams of glucose converted into moles. Mass divided by molar mass is equal number of moles. Then you can see mass divided by molar mass, 2.58 moles of glucose present at the beginning. Now let's go back to the equation. 1 mole of glucose reacted to produce double that amount, 2 moles of C2H5OH, 2 times of ethanol. So 2.58 glucose amount reacted to produce 2 times of this amount ethanol. Then you can calculate ethanol moles. 2 times 2.58, that is 5.17 moles of ethanol produced. Now we need ethanol mass. Then ethanol molar mass is 46.068. Moles multiplied by molar mass is equal to 38 grams. That is one answer. The next answer we need in liters. For that we need density. Density is 0.789 grams per milliliter. The meaning is 0.789 grams in 1 milliliter. 0.789 grams in 1 milliliter means 238 grams in how many milliliters? You can use this conversion factor. Conversion factor means a fraction. 0.789 grams equal 1 milliliter equality. You can write as a fraction. One is 1 ml divided by 0.789. The other fraction you can switch the numerator and the denominator. 0.789 divided by 1 ml. But for this part we need only this conversion factor because 238 grams, the grams should be in the denominator. Then we can cancel grams, unwanted units. 238 times 1 divided by 0.789 is equal 302 milliliters. Let's talk about our last question. Consider the reaction given. The reaction is already balanced. There are 2 reactants in the reactant side, MnO2 and 4 moles of HCl. And the product side, there are 3 products given. Now the question is, if 0.96 moles of MnO2 react with 52.2 grams of HCl, what is the limiting reactant? Limiting reactant meaning is which reactant, MnO2 or HCl, consumed first. Part 2 is how many grams of Cl2 will be produced. There are 2 parts. So let's go and find out first what is the limiting reactant. To identify the limiting reactant, we need moles of MnO2 and moles of HCl available. Moles of MnO2 already given in the question, but moles of HCl we need to calculate. We have gram quantity. Let's convert grams into moles first. For that we need molar mass of HCl. It is 36.46 grams. So grams divided by molar mass convert into moles. Now 1.43 moles of HCl available. You have MnO2 and HCl in moles now. 0.96 moles MnO2 and 1.43 moles HCl. Let's think which one is the limiting reactant. The MnO2 and HCl reactants react together in this molar ratio, 1 to 4 molar ratio. Let's think if all 0.96 moles of MnO2 completely consumed first, or another name is the limiting reactant. According to molar ratio, 0.96 times 4 times of 0.96 amount should be available here to react with that. That is 3.84 moles of HCl should be here if all 0.96 consumed. Then look at the amount available. Only 1.43. We don't have this much. Then this is not the limiting reactant. Then 0.96 is not our limiting. It is not consumed first. Let's think the other way. If all 1.43 moles consumed first, according to molar ratio 4 to 1, 1.43 divided by 1 amount should be here. That is 0.477 moles. We have more than that, 0.96 moles. HCl Therefore, HCl is our limiting reactant, the reactant consumed first. All 1.43 completely consumed in the reaction. With that amount, 1.43 divided by 4 amount, according to this molar ratio, MnO2 reactant. Now, first question answer is we already find 1.43 moles of HCl. HCl is our limiting reactant. Let's go to part 2. How many moles of Cl2 produced? How many grams of Cl2 produced? Number of moles of Cl2 produced and HCl. What is the connection? Let's go to the equation. 4 moles of HCl reacted to produce 1 mole of Cl2. Again, the molar ratio is 4 to 1. 4 amount needs 1/4 amount of Cl2. Then 1.43 HCl reacted means 1.43 divided by 4 amount of HCl produced. That is 0.358 moles. The question asks the grams of Cl2, not the moles. So let's convert moles into grams. Cl2 molar mass 70.90. Any number of moles multiplied by molar mass gives a gram quantity. Moles multiplied by molar mass is equal mass. That is 25.3 grams of Cl2. I hope now you are understanding the moles, molar mass, grams concept, how we can interconvert each of these terms. Thank you all for watching. If you find this helpful, please subscribe to the channel for more learning.